When it comes to extending Blade's functionality to do more things, the only way mentioned in the docs is how to register your own directive. But there's actually a couple more ways to do it, which can be useful in some situations. So we're going to take a look at a couple of ways to add to it. Remember, in the compiler engine, the get method initiates the compilation on the Blade compiler itself. If we follow that through to the Blade compiler's compile method, and then the compile string method that calls, we can see one of the first things it does here is running the Blade file's contents through a set of precompilers. But it only does this after stripping out the comments, verbatim blocks, and compiling component tags. So it's not the very first thing that happens. These precompilers are just callbacks that get invoked before the main compilation step happens for the majority of directives. The callbacks come from a property on the compiler class, and if we want to add a new precompiler to the list, we can just call the precompiler function ourselves and pass one in. So let's do that in our own service provider. The Blade facade is actually a reference to the compiler class itself, so we can just use that to register one. But what kind of thing would be useful as a precompiler that we can't do by registering a normal directive? Well, a normal directive is just like a string replace, but you can only affect a very specific thing. A directive is an @ symbol followed by the directive's name, followed by its argument in parentheses. If you wanted to do something more than that, a directive can't really help you there. Let's make our precompiler run the preg replace function over the Blade file so that we can use a regular expression. We'll make a new quote-unquote directive by finding the string @trim in the Blade file and replacing it with an empty string to remove it entirely. But here's where it gets interesting. We can now effectively use source code before and after the directive. We can search for whitespace using \s* on either side of the directive to capture that and remove it as well. So when would this new @trim sort of directive precompiler hybrid come in handy? Well, let's imagine we've got a text area with a default value. We should know that we can't really have whitespace inside a text area, else the line breaks and indentation will actually be part of the form value on the front end. And we can see that the text area's value does actually have that whitespace. So we can wrap our trim directive around either side. It doesn't really matter where it goes. We could put it on the same line as the closing text area tag or the opening one, and it'll work exactly the same because it's just looking for any whitespace. And then the compiled file won't have any whitespace around the value, just like we want. And we can see the text area now has no whitespace around it. Perfect. And additionally, if we look at the compiled view in Storage Framework Views, we can see that all of the whitespace around the value itself has actually disappeared. Okay, so this isn't the most extravagant or practical use case, but you can see how we could use a precompiler here. For a more realistic example, the Livewire package actually registers a precompiler. If we check out the Livewire service provider, we can see it registers a callback that puts the Blade file through the Livewire tag compiler class. If we look at that, we see it's just full of these huge regular expressions, but what it really does is find HTML tags starting with livewire : and then replaces them with @livewire directives. It's pretty much exactly the same way as regular Blade component tags work. Anyway, if we go back to the Blade compiler class in the compile string method and continue on, the next bit that happens is the Blade file gets split up into separate PHP tokens and passed individually. When a token does get passed, it goes through a handful of compile methods that come from a property. If we look at that property, we can see the first one of them is compile extensions. As we can see, this is pretty much exactly the same as precompilers. It just runs the contents of the Blade file over a callback. And we can register them in the same way as the precompilers just by using the extend method. To prove that works, we can go back to our app service provider and just replace the precompiler method with extend. And if we refresh the page, we can see our trim directive is still run because there's no whitespace in the text area. And this still happens before the main compilation step, so there's not really much difference between extensions and precompilers. The only notable difference is that the extension callback doesn't necessarily get the full Blade file. Because it's been split up by the token getAll function, any Blade files that have raw PHP tags in them will be split up. For example, if we had a real PHP tag in our Blade file, the extension method would first get this section, and then the second section, and the callback would be called twice, one for each time. And I just want to show something else that makes use of this. The developers at Pinecode released a package that uses extensions to introduce filters to Blade to make a syntax that's more relatable to Twig developers, which is a really interesting use case. You can see it has the regular Blade syntax, but instead of calling a function, you can pipe a value into another function, and you can do that as many times as you want. Again, this is basically precompiling it before Blade compiles the main file itself. And like I said, this is pretty similar to Twig syntax. But it's all made possible through Blade precompilers and extensions. So you can introduce a lot of new syntax, do additional things that you can't normally do with directives, and that's how you can add your own functionality to Blade.